In this problem, we have a single loop of wire where the area of the wire is being reduced in a certain amount of time. The magnetic field is pointed upward and constant. What is the EMF? What is the electromotive force that's induced inside of this wire? So in electromagnetism, Faraday's law says that the EMF is equal to negative the number of loops times the change in magnetic flux divided by the change in time. Well, it doesn't just say the magnetic flux changes by some amount, but magnetic flux is equal to the magnetic field times the area times the cosine of theta. And so we're just making that substitution. And what's changing here is the area. Because the area changes, the magnetic flux changes, that induces an electromotive force. So imagine we have this loop of wire. It has a magnetic field inside of it. The wire is shrinking, so the magnetic flux is decreasing because of that change in area. Well, the way we measure this angle is a little bit different. When we measure the angle, we have an imaginary normal line here that's perpendicular to our wire. The magnetic field going upward is here. Well, this magnetic field is parallel to this normal line, so we use an angle here of 0 degrees. It's a little different the way the angle is measured with Faraday's law. So this cosine of 0 degrees is just going to equal 1. So we need to take our one loop of wire times our magnetic field, which is a constant 0.9 Tesla, times our change in area, 0.4 minus the original area is 1.8 meters squared, times cosine of 0, again, that's just 1. Divide that by 0.33 seconds. So entering this into our calculator, -1 times 0.9, that negative sign is part of Lenz's law, times 0.4 minus 1.8 times cosine of 0 is just 1, then divided by 0.33. And so we get an EMF of 3.82 volts.